Hi there, Mr. Sutton with the Pre-Cal Honors 3-1 Extra Practice Number 3 Solutions on Simplifying Rational Expressions. To simplify this problem, since there's no way to factor this any further, we're just going to reduce. So 3 and 24, those can reduce together. That gives me a 1 up here and an 8 down here. X to the 5th and x to the 4th can also be reduced. Using our exponent rules in subtracting, that's going to give us an x to the 1st power upstairs. And now taking stock of what's left over here, the whole fraction's negative. We have just an x in the numerator, and in the denominator all that's left is this 8. So negative x over 8. On this problem, we're going to first factor before we try canceling anything out. So the numerator can't really do anything with that. I'm just going to rewrite it. But in the denominator, we can take out a common factor of 7. That will leave us with 7k plus 9 inside. And let's see, can't do anything with this 7k plus 9 factor, but 7 and 21, those can cancel a little bit. So that leaves me with a 3 in the numerator. And in the denominator, that's just an invisible 1. So up top, we have a 3 times k squared. In the denominator, we have basically just this 7k plus 9. For this problem, to simplify it, we have to do absolutely nothing. We can't factor this any further. These factors themselves are not the same factor, so we can't just outright cancel it. There's no way to split these x's off into another fraction using multiplication, so this is already simplified. To simplify this rational expression, let's start by factoring as much as we can. So in the numerator, we can factor out a 2, leaving me with x minus 5. And in the denominator, I can take out a common factor of 8. That leaves me with an x and also a minus 5 down there. The 2 and the 8 can reduce. That's going to be a 1 over 4. And then these x minus 5s are exactly the same factor, so those cancel completely. And up top, we're left with, well, everything got crossed off, so there's still an invisible 1 that we now need to be not so invisible. And downstairs, all we have left is 4. To simplify this rational expression, let's begin by factoring as much as we can. So in the numerator, we need factors of negative 32 that add up to negative 4. Let's see, we've got 1 and 32 doesn't work, 2 and 16 doesn't work. 4 and 8 works if you have positive 4 and negative 8. So we've got v plus 4, v minus 8. And in the denominator, I need factors of 56 that add up to negative 15. So let's see, we got 1 and 56, 2 and 28. 3 doesn't go into 56. We got 4 and 14. 4 and 14 doesn't quite work. What else is there? 7 and 8. Yeah, 7 and 8 works if they're both negative. So v minus 7. v minus 8. And these v minus 8 factors, they're exactly the same, so I can cancel those out, leaving me with v plus 4 in the numerator and v minus 7 in the denominator. To simplify this expression, we're going to have to start by factoring as much as we can in the numerator and denominator to find common factors. Now, I'm going to start by taking out the greatest common factor from each one. The numerator, there's no GCF to take out. But in the denominator, we can actually factor an x out of all these. So I'll leave my numerator the same for now. We'll factor it more fully in a moment. But in the denominator, if I take an x out, I'm left with x squared minus 15x plus 56. And now let's factor a little bit more. So back in the numerator, I need factors of 72 that add up to negative 17. So we got 1 and 72 doesn't work, 2 and 36 won't work, 3 and 14, yeah, 3 and 14 would work. No, 3 and 14 won't work, 3 and 24, so we got to keep going. 4 and 18, that's not going to do it. 6 and 12 is close. How about 8 and 9? Yeah, negative 8, negative 9. So we've got x minus 8, x minus 9. And now down below, we're going to carry down that x. We can't lose it. But we need factors of 56 that add up to negative 15. So we got 1 and 56, 2 and 28, 4 and 14, 7 and 8. 7 and 8 works if they're both negative. So x minus 7, x minus 8. And it looks like these x minus 8s are the only factors that actually cancel. So in the numerator, we just have an x minus 9 now. And in the denominator, we still have an x and an x minus 7. And there's no need to distribute that. You can just leave it like this.